Thank you, Aline, and good morning, everyone, also from my side. And thank you for inviting me to this very interesting focus session. I hope you can hear me loud and clear.
We can.
Thank you. So after this very interesting discussion at the business level, I will try now to translate this topic into more functional and technical details with my presentation today, where I'm going to share some insight about the non-time critical functional solution that we as Banca d'Italia, as a service provider of tips, we put in place for answering the request of raising the detailed assessment of the change request tips 41, just to give you some background information that is currently ongoing and under finalization on our side. So before starting, some preliminary remarks relating to the principles we use to approach this investigation. So first of all, the main point is that the non-time critical traffic and service is expected to reuse the same messages that are currently in use, for example, on the SEPA credit transfer instant implementation guidelines. So we had to differentiate the flow at network protocol level, and our proposal was to add a dedicated suffix at the protocol envelope layer in order to make sure we can segregate the real instant traffic with the, let's say, fast non-instant traffic. On top of that, as a market requirement, we have been asked to add also some elements at the level of the payload in order to clearly mark the transaction as a non-time critical. So based on the explanation, so these two items, on our side, we have to secure, first of all, the current behavior of the TIPS machine. Since TIPS machine is highly oriented and optimized to process instant payment flows, whose life cycle is very short in our internal components. So in a matter of seconds, the payment enters, gets confirmed, is settled, and then is, let's say, moved out of the core function. Now, the paradigm will mix in the same system real instant traffic and fast payment, non-time critical, resulting into the potential distortion of the core functioning, because we are very well equipped to manage the instant traffic, but payments whose life cycle could extend up to 6 hours could become a problem in terms of performance. That's why we try to design some new component, maybe looking at the next slide, to reply and to answer the main requirements that have been listed in the CR41. So just as a recap, the non-time critical traffic is expected to have a life cycle of a few seconds up to 6 hours, meaning that if the beneficiary PSP is in a position to respond immediately, there is no, let's say, stop at the level of the central system. We will set the transaction almost immediately following the instant paradigm. Of course, as I mentioned, we had to take into consideration all the mitigation measures to avoid the impact on the concurrent instant traffic. We have been asked to introduce a new use case. Since we have 6 hours, the customer, the originator PSP, may decide at a certain point in time, if there is no response from the beneficiary PSP, to cancel the pending transaction. And to support all the abnormal scenarios investigation, there will be the possibility to inquire the system to make some investigation about the status of a pending non-time critical, and also for the beneficiary PSP to send an unsolicited status update just to inform the central system that the payment has been received by the beneficiary, but it has not confirmed yet. So it's a kind of intermediate status that could be conveyed back to the originator just to avoid the retransmission of the same transaction. So moving to the next slide, few highlights on the high-level functional design. Because the main innovation that we proposed with the CR41 is a new component that will act at the level of the interface between TIPS and the network service provider layer that will take care of managing the non-time critical transactions in isolation compared to the regular instant traffic. So this component will consume the NTC transactions from the queues of the NSPs. On the other hand, shielding the TIPS core layer, which is the place in TIPS where settlement occurs, in order to avoid the issue I mentioned at the very beginning, that having a long-lasting transaction could impact the performance of the concurrent instant traffic. So there will be an isolation of the non-time critical traffic at the level of this new component that will take care of validating, for example, the correctness of the message from an XML viewpoint. There will be a check on the validity of the corresponding reference data configuration. The layer will also take care of routing the payments from the originator to the beneficiary. And we will see later on also an internal routing function from this new component towards the TIPS core. And the last but not the least, very important, we introduced a concept of waiting list function. And in a nutshell, the waiting list will support the system, since there will be, for non-time critical, no reservation of funds when the transaction is received from the originator. So this will be, let's say, a deviation if you look from the perspective of the standard SEPA credit transfer. When you receive the message, you reserve and secure the funds, you send to the beneficiary, and once the beneficiary sends the confirmation, you settle. The waiting list will fill the gap by providing additional pros and contemporarily mitigating the risk of overflooding the core with a number of attempts that will, by definition, take more than 20 seconds. So moving to the next slide, I think entering into the details, here we are talking about the function, the way the new component will work vis-a-vis the TIPS core. So this is the internal communication that will be used whenever there is a non-time critical message received, will be processed by the component. The message will be forwarded to the beneficiary PSP. And once we get the confirmation from the beneficiary PSP, so we have the green light to settle, this component will submit a request towards the TIPS core using the standard channel. So in that point of the platform, we will have both the instant and the near instant traffic at the same time in the same loop, but following the same rules. So the payment will be injected, will be processed immediately by the core. And in case there is a rejection due to, for example, lack of liquidity, the payment will be put in the waiting list for further processing after some time. So the waiting list feature is a key way to optimize the lack of reservation of funds. You may wonder why there could be no reservation of funds for the non-time critical, and the answer is, let's say, rather technical, but I will try to explain. Unfortunately, the reservation of funds is a feature that is offered at the level of the core in the regular flow. So whenever you do all the processing, all the validation, you submit the payment at the core level, and then you reserve the funds. We couldn't do the same for non-time critical for the reason I mentioned before, because following the same rule and keeping the reservation of funds at the level of the TIPS core will have the side effect of maintaining the transaction potentially in the core for more than 20 seconds, up to 6 hours. And that was exactly what we wanted to avoid. The waiting list feature I mentioned will fill the gap because we'll try to orchestrate the settlement attempts without the involvement of the originator and beneficiary PSP any longer. So they did their job submitting the transaction and confirming the non-time critical. Any settlement reattempt will be managed internally by the system within the 6-hour time frame. And also we introduce a concept of a smart reattempt in the extreme scenario in which on the debiting side there is no sufficient balance to cover the non-time critical transaction. So in order to manage this, the idea was to rely on internal notifications from our liquidity management component. So whenever some fresh liquidity is either received from the RTGS system or is credited due to other transactions on the same account, the waiting list will activate a settlement reattempt just for that payment insisting on that account, because we know that fresh liquidity has arrived, so we have a higher likelihood of settling with the next settlement attempt. I think we can move to the next slide just to provide some general visual representation on the architecture. So we have a network layer that will take care of segregating the flows by using a different suffix at the network protocol layer. You may be familiar with .EPC suffix, which is currently used for marking regular SEPA credit transfer instant payment. We will add a similar suffix just for NTC, so that when the payment lands on the system, we will know simply by looking at the network envelope what is the right component that should cope with it and what is the schema validation that we should apply. I think we have some additional slide on the workflow. Yes, just to explain with a visual representation what I mentioned, what I anticipated before. So we have a non-time critical payment originated by a PSP that will reach the TIPS NTC component. This will activate a number of validations, and as a successful result of these validations, the payment will be forwarded back to the network protocol layer, aiming to reach the beneficiary PSP of the non-time critical. So with step 4, the beneficiary PSP will be informed about the transaction, and they may decide to respond immediately via message number 5, confirming the willingness to settle the non-time critical. If this is the case, the payment will be immediately transferred, I think, with the next slide, so after step 5, with step 6, by the TIPS non-time critical component towards the TIPS core. This will be very fast, so we will move the funds on the 2 accounts. We will confirm back the successful settlement, and then we will inform the 2 stakeholders that payment has been settled. So This is the way we shielded the resources of the core, because the settlement at step 6, 7, and 8 will take no more than a normal SEPA credit transfer instant. And in case we have a rejection at step 8 because there is an internal failure due to a lack of liquidity, the TIPS waiting list will simply attempt again to send the message number 6 after some time or when there is enough liquidity on the debited account. Moving to the next slide, I think this is just a recap of the non-time critical use cases that will be managed directly by the component. So I mentioned the cancellation, so the possibility for an originator to cancel a transaction that is still within the 6 hours and it is still pending. We have inquiry mechanism. The retry of settlement attempt now should be discussed with sufficient details. But in the end, the waiting list will take care of the whole payment life cycle and also the timeout management. Because in the end, after 6 hours, if there is no confirmation from the beneficiary PSP, we are still forced to close the transaction from a central system viewpoint. And last but not the least, this component will also take care of sending back both to the originator and beneficiary PSPs the confirmation messages, so the PAX2 for the non-time critical transaction. Maybe one additional point that is not mentioned in this list of use cases, but it might be relevant for those of you who are not familiar with the requirements of the TIPS 41. There was a specific request to set up some reference data flag in our common component to basically opt in or opt out the feature from a business viewpoint. So from a beneficiary viewpoint, you may decide to flag non-time critical acceptance in the reference data, and this information will be published into the TIPS directory that we deliver on a daily basis to all the subscribers. So with this flag, basically, if you set to false, what the system does is simply preventing any forwarding of the non-time critical to those PSPs who opted out the service. So immediately from the central viewpoint. So you will not even receive the non-time critical message from the central system. As a conclusion, in the next slide, just some key point for discussion. Basically, our main objective was not to create a segregation of liquidity on the TIPS accounts or the TIPS ancillary system technical account when introducing this new service. So the same pool of liquidity with the same accounts and the same static data configuration will be fully reusable for both regular instant and non-time critical instant, non-time critical payment. Using the architecture I described, we mitigate any risk of creating issue on the current TIPS architecture, and we kept the traffic segregated. So technically, the different SLA can be guaranteed in parallel. Also, from a liquidity management viewpoint, you may wonder that non-time critical could lead, in theory, to long-lasting reservation of funds, or maybe peaks of reserve liquidity due to a bulk that is attempting to debit the same account in TIPS. So all these points will be addressed seamlessly due to the introduction of the waiting list and the absence of any reservation of funds. So still we can keep the workflow lean, but we avoid that we block liquidity for a very long time, up to 6 hours on some accounts. Last point is just a remark that is overcoming one of the limitation that we identified during our preliminary assessment for the same CR. At that time, we didn't provide such an efficient solution. So using the same TIP score, we were forced to have a limitation in the concurrent number of pending non-time critical payments that we finally were able to remove completely. So at the moment, there is no limitation. There will be some throttling mechanism implemented both at the NSP side, but also at the level of the NTC in order to make sure that we are not receiving a high number of transactions per second at the same time that could prevent the normal behavior of the system. I think I reached the end of my presentation, so maybe I can give the floor back to Aline and open for any questions.
Yes, thank you, Andrea. Lovely. Thanks so much. That was a lot of content. I think everybody skipped lunch and had espressos because it went absolutely mad in the chat. But we are going through the questions here, and I think we've answered most of them, guys. Everybody listen up here. So we have answered most of the questions that you are shooting at us. So this is the good news. And the even better news is that we will publish everything on our web pages. So you can rewatch this as many times as you like and go through the slides and also watch again the panel, because the panel also answered a lot of your questions in here. Maybe, Andrea, I just want to have one quick question for you, because it seems like there's someone asking here quickly. Will NTCs still receive confirmation of credit to the payee? I assume the answer is yes, but can you maybe highlight me on that?
Yeah, if here we are talking about confirmation to the payee, meaning in the sense of distant payment regulation, indeed the beneficiary PSP will be in a position to confirm to the central system when they credited the funds to the ultimate beneficiary. There is no, let's say, requirement or constraint from a flow viewpoint. We are mimicking with the current solution of the non-time critical, the former flow of the SEPA credit transfer instant, in which, in theory, the beneficiary PSP can decide whether waiting the confirmation from the central system before crediting the ultimate beneficiary, but also the other way around. So they can simply confirm immediately and then confirm back to TIPS and wait for the successful settlement. So
super. Thank you, Andrea. Thanks so much for joining us today. That was a lot of good content here for everybody to digest.